Hello everyone, I am Ahmed Sharaf. I am studying materials engineering. Today I am talking about an important material which is extensively used in many applications around us. So it's called indium tin oxide. Indium tin oxide is used in mobile phones and laptop screens, OLED TVs, and in sunglasses to protect you from the harmful radiation. The uniqueness of this material is it transparent and at the same time it is electrically conductor. So how it's happening? We are familiar with this illustration of valence band and the conductive band. The Fermi energy in a half distance between the valence band and the conductive band. If we apply some light to that material, some electrons can be excited to the conduction band and leave behind some holes. With applying some potential, it will be able to conduct electricity. Visible light energy ranges from 1.6 and 3.3 electron volts. For a material has a band gap lower than 3.3, so the material's color will be black or get colored. But for a material which have band gap energy higher than 3.3 electron volt, the light will transmit through the material and become transparent. Here in this list we see various metal oxides, and the indium oxide can compete for our purpose. For highly doped indium oxide with 10 more than 10%, we can get the conduction band below Fermi level so that indium tin oxide becomes electrically conductor. Now, what happens to higher energies or lower energies than the visible light energy? For very high and very low energies, it will be absorbed by that material without transmission. So it can be used for protection from the harmful ultraviolet and infrared radiations. Finally, we can see from this picture a piece of indium tin oxide which is transparent and at the same time electrically conductor. And in this graph, the wavelengths corresponding to transmittance, we can see here above 300 nanometer, the percentage of transmittance is very high, approaching about 90%. And we see also the doping effect on the concentration, carrier concentration. At very high doping percentage, we see the carrier concentration is very high. And finally, we can see indium tin oxide layer placed in between other layers to make touch screen. Here we are for some applications of indium tin oxides. We can use it for street lighting, also for protection windows in aeroplanes, and for solar cells, and lastly for OLED TVs. Thank you for your attention and listening.